says that if more than 7% of households in a city exceed the safe limit, the city needs to switch to bottled water. Okay? All right, after some news reports of acid rain, the concerned citizen takes this random sample of 100 households around the community and finds that 25 have unsafe water. 25? I can read. It says 12, right? Bruh. 12 have unsafe water. All right, do the data provide convincing evidence that the Washington, or the WA community, I don't know, should switch to, oh, it's West Allegheny, I can read too. Communities should switch to bottled water. All right, so first things first, state the appropriate hypothesis. All right, is this proportions or means? Proportions, okay, so that's the first decision we have to make, okay. So that means I'm using the symbol P, right? All right, and what is the claim? 7%. That's safe, right? But what are we afraid of? It's more than 7%. So this would be safe, and this would be unsafe water, right? Now, let me expand your logic for a second. Wouldn't it be true if I said that this was less than or equal to, that's still safe? So any sample I take falls into one of those two categories now, right? Doesn't have to be exactly 7%. If it's less than, it's still okay. Yeah? Okay, so you don't have to write your null that way, but sometimes you'll see it, and I don't want that to throw you off. All right? What you have to be clear about is the alternative. Now, after conducting a significance test, a p-value of 0.025 is found. Interpret the p-value. All right? Don't worry about this. We don't have to do that. Reject or fail to reject. What did Snoop just tell us?
If the p is low, then the null must go.
The null must go, right? Don't write it. So, all right. Since the p-value is 0.025, how does it compare to the significance? What is our significance? It tells us right there, 0.025. You see it on number 1?
Yeah.
0.05. So, less than or greater than? Good. So Snoop says, the null must go. We must reject the null. All right. Now, let's just leave it at that for now. What does that mean in this context? If we reject the null, what did the null mean in this scenario? What are these numbers referring to? Like, what are we talking about? Water. What did the null referred to? Safe water, right? Yeah, with me? Nick, are you with me? The null meant that the water was safe. So if we're rejecting this, what are we saying? We have really strong evidence that the water is unsafe. Yes? Okay. What is the consequence of this in this community if we say, hey, the water's unsafe? What's going to happen? Can't use the water, so what are they going to have to do? Go buy a bunch of bottled water, right? All right. So that's what this lesson is about. What is the consequence? The community now has to rely on bottled water, right? That's what I mean by what's the consequence of this decision. Now, I don't know how you would know this, but on D it says if the water is safe, meaning if we made a mistake and the water was really safe, even though we told the community it wasn't safe, the probability of that happening is whatever the alpha level is. So in this case, it's 0.05. So that would mean it's the probability of being safe but we told them unsafe. Now, you're going to see me do this a few times too in this lesson. I have the null and the alternative. I'm just using symbols. And over here I'm going to put my decision, and over here I'm going to put what is the truth. All right? So in this scenario we're saying that we rejected the null, but the water was actually safe. Right? You tracking with me? This is what we call a type 1 error. When you make a mistake in your decision. Okay? That's what this lesson's about, is the errors that we make sometimes, because everybody makes mistakes, right? Do you want me to play the music?
Except for Dylan.
Except for Dylan, he didn't make mistakes?
No.
All right. He's not digging that. This is called a type 1 error with the Roman numeral 1. Type 1. Because the first hypothesis was actually true, even though we said it wasn't. All right? Now, I know that really feels foreign and weird and all that, but we'll get there. We're going to practice it, I promise. Okay? Now, suppose the p-value that we ran the test and the p-value is 0.217 instead. Would we reject or fail to reject in that scenario? Think about it. Our p-value is now 0.217 compared to 0.05. What would Snoop say?
Reject. The null.
If the p is low, we reject the null. Is this lower than that? So we fail to reject. We failed to reject. Snoop, don't talk like this. We failed to reject the null, okay? All right, so in this case, decision, true. So in this case, we failed to reject it, which means we landed at the null being our truth. So B says, well, what if this is wrong? What if the real truth was that the water was really toxic, but we told the community it was fine? People are going to get really sick, right? People could get really sick. That's a problem. Now, are the consequences, think about the two consequences we said. They have to go buy a bunch of bottled water versus people get really sick. Which one's more serious? Sick, right? Yes, obviously, you know this. People getting sick is more serious. Not a hard decision to make, right? Now, what we just saw, the second type of error, it's very hard to, is type 2. Now, how do I remember this? It's cheesy. But if I run my test and I come down to my decision and Snoop says fail to reject, guess what? It's a type 2. It could be a type 2 error. Fail to reject. Okay? That means the other one has to be type 1, right? There's only 2 types. All right? It works for me. You do you. All righty? We okay so far? It's very heady, I know. It's very heady. A lot of words going on here. All right. We okay? Yeah. All right. What's that? What was that? My phone? Oh, I wasn't talking to her. Okay. So here's this lovely little table of all the possible decisions we could make when we do a hypothesis test. And we determine What is true? Okay, based on our evidence. All right. If we, and this is in stats language, so let's just chew it up and figure it out. All right. If we rejected the null, but the null was true, the claim is true, we rejected it, that's a type 1 error. If we rejected the null and the null was false, actually that was correct, that is a correct outcome. Okay? We correctly rejected the null. We do that sometimes. We're going to get it right. There is a special name for this that's coming in another week. We'll talk about it in another week for this, a good decision. This is why I told you we do chapter 9 really slow. Remember that? Do you trust me?
Yeah.
Huh? All the chapters like this? Can't do them all like this. If we fail to reject the null, and the null was true, that's correct. This language is weird, I know. If we fail to reject the null, but the null was false, then that's a type 2. All right. It's supposed to be what? Huh? What? What's wrong?
Pop my elbow and it's really loud.
Oh, dude.
Play the violin.
There you go, Nick. It's in the video for all posterity, too. So. You're going to be famous. That was the homecoming king. His elbow just popped. And we felt really bad for him. Okay. Anyway, type 1 error. Yeah, it's recording. It's always recording. See this little guy right here?
Has it always been? So if I just
Yes, Bennett. If you just screamed and
then it would be in there.
You don't hear any audio, you see Snoop Dogg pop up on your screen.
you know what? I'm gonna post this video like after y'all leave, and y'all can go listen to it again if you'd like later, just to relive this moment.
It's gonna be my music class.
Because it's gonna take there's a lot of vocab in this chapter. It is a lot. So I get it. You're gonna have to give yourself time and the attention to give yourself repetition to get all this down, right, Aparna? Mm-hmm. Right, Jordan? Mm-hmm. So a type 1 error happens when we reject the null, or it could happen when we reject the null. Anytime you reject the null, it could be a type 1 error. The probability of a type 1 error is, do you remember what we said?
The significance.
Good. The significance level, which we symbolize with a little fish, alpha. It's the Greek letter alpha. Not a fish. Type 2 error could be happening when we fail to reject. It's not a fish. It's the Greek letter alpha. You do you. If you need to draw it as a fish, whatever. All right. It's the Greek letter alpha. That's what mu is. Mu is a Greek letter. Even the P we use for proportions is a Greek letter, rho, but we don't call it rho. We call it rho. I know. Well, in Greek it's more like cursive, but whatever. All right, let's try this out. Mr. Brown purchased a trick coin. We'll see if we can get through this. He purchased a trick coin that's supposed to land heads up 75% of the time. One of his students volunteered to test the claim. He flips the coin 50 times, and he found the coin that lands heads up 35 times. Student then performs the test of the following hypothesis at a 10% significance level. So notice that changed a little bit, didn't it? All right. So they gave us the null and the alternative. See how it's a little curly P? That's really rho. R-H-O is how it's spelled in Greek, but who cares? Rho is, P is 0.75. So let's see. Is it less than? Is his coin really good? Where P is the true proportion of tosses that the coin would land heads up. Now, y'all gotta hang on for this ride. Describe a type 1 error. And a type 2 error in this setting means in this context. So what I would do first is come back up here and next to my null and alternative, put the context with it. What does this value really mean in the context of this question? 0.75. Landed heads up 75% of the time. Would that mean the coin is fair? What is he's testing the coin.
If it's true.
Yes. The coin is a trick coin, right? Coin is truly a trick coin, right? How do I say it better? Coin is heads. Okay. Is heads 75% of the time. Y'all are so judgy. Oh my gosh. Way too comfortable with me. There you go. Coin. The coin is heads 75% of the time. What it's supposed to do, right? So then what does the alternative mean here? Coin is not heads. You can keep it that simple.
Coin is no trick.
Is, or you could say heads less than 75% of the time, right? Now, just shaking your head like whatever. Just get through this. Type 1, type 2. All right, type 1. What did we say type 1 is when we rejected the null, right?
Yes.
That means we found evidence for the alternative. So let's put that in words. We found evidence that the coin is heads less than 75% of the time. But in reality, because we were wrong, what was the truth? All right. So if we found evidence that it's heads less than 75% of the time, but in reality, it is heads 75% or more. It's the opposite. See what we did? We just said the opposite. So the hardest part of this is figuring out what's the first phrase. Which way is it the first way? And then you say, but in reality, it's, and then you fill in the gaps with the opposite. All right? We'll pick up from here tomorrow. So, because it could be more, and that's great. That's what it's supposed to be doing. All right? So, yesterday we talked about type 1 error. Type 1 is when you reject the null incorrectly. So you rejected this, but it was actually true. So how do we put that in words and context? We said we found evidence that the coin is heads less than 75% of the time, but in reality, it's 75% or more. You with me? So then type 2 is the opposite. Type 2 is when you fail to reject, but you make a mistake. So type 2, so we failed to reject the null. That means we found evidence that the null is true. So what does that mean? We found evidence that the coin was heads at least 75% of the time. No, don't do that. But in reality, what was it? It was less than. Okay. So the trick on identifying your errors is this first piece. Found evidence for what? Okay. Less than 75% of the time, that's the alternative, right? Or a type 2 is when we found evidence of the null. And then reality is the opposite. That's all. All right? Now, which type of error that we described would result in Mr. Brown returning the coin and writing a negative review of the product? Don't know. You think 1, you think 2. Which one is more like, yeah, which mistake is going to mean that he's going to return the coin? So it's not about what reality is, it's about what we found evidence for. Is that clarified a little bit? It's like, what did our evidence show? So that would be a type 1. You with me? Okay, thank you. It's confusing, I know. No? Don't see it?
I thought I had 2 at first, too.
I think that's the way I said it. Because at type 1, it looks like the coin is not doing what it's supposed to be doing, right?
Yeah.
Which would make Mr. Brown say, whatever, I'm returning this, giving you a bad review. But in reality, it was just a bad sample, right? The coin was fine. But he gave him a bad review anyway. So it's a mistake either way, right? Both of these are mistakes. So which mistake is going to mean he's going to return it? Type 1. Does that make sense now? Okay. Yes. All right. Type 1. Now, if the students were to use an alpha of 0.05 instead of an alpha of 10%, would this make it more or less likely to reject the null when the null is true? You remember what that's asking you? Remember the probability of a type 1 error is alpha, right? So the chance of making that mistake that we just described is alpha. So originally in our question, it was a 10% chance of making that mistake, right? So it's saying, okay, what happens if I change my alpha to 5% instead of 10? Am I more or less likely to reject the null? What'd you say? Less likely, like 5% is less than 10%, right? So you don't have to overthink that, okay? 5% is less than 10%, so less likely make a type 1 error. All right. So that finishes that simulation.